Section 2.5 is radical equations. We're going to solve and check. Number one, first thing we want to get x by itself, so we need to do the inverse of this square root, which to undo a square root, you square both sides. Whatever you do to one side, you're going to do to the other. So we're left with 4x plus 1 equals 9, and now it's just a simple solve an equation procedure. 4x equals 8. Divide both sides by 4, and x equals 2. Now we want to check x equals 2, so we're going to plug 2 back into our original problem. Everywhere x is at, we're going to put a 2. And so that's going to be 4 times 2 is 8, plus 1 is 9. The square root of 9 is 3. 3 equals 3, so we check that solution checks. In number 2, we're going to do the same concept. To undo a square root, we square both sides. Whatever you do to one side, you do to the other. So that leaves us with 6x plus 7 equals. Now we have to go off to the side and boil x plus 2, which is going to give us x squared plus 2x plus 2x plus 4, which is x squared plus 4x plus 4, and we're going to put that here. X squared plus 4x plus 4. I like terms, so we want to subtract 6x from both sides. So we get 7 equals x squared minus 2x plus 4. Subtract 7. We want to get 0 over here is equal to x squared minus 2x minus 3. Okay, we want to factor this using rooftop. What multiplies to give us a negative 3, but it's going to add to give us a negative 2, which is going to be a negative 3 and 1. So this becomes x minus 3, and this one becomes x plus 1 equals 0. You set each component equal to 0. X plus 1 equals 0, and solve. Add 3, so x equals 3, and x equals negative 1. So now we're also going to check our work. Okay, I wrote the original problem down, but everywhere x is at, I'm going to test 3 right here. So that's 18 plus 18 plus 7, which is going to be 25. Square root of 25 is equal to 3 plus 2 is 5, so 5 equals 5. This value checks. Next, we plug in negative 1 everywhere x is at. That's negative 6 plus 7 is 1. The square root of 1 equals negative 1 plus 2 is 1, so 1 equals 1. Both solutions check. Okay, next we're going to talk about the absolute value property. Basically, it says when you have absolute value of x, you're going to get p, which implies you're going to get a positive p and you're going to get a negative p. So simply looking at number 3, the two solutions to this is going to be 5 and negative 5, because absolute value is asking us the distance from 0 on the number line. So in both directions, you're going to go 5 to the right gives you this, 5 to the left gives you that. And also, likewise, since absolute value is talking about distance, it cannot be a negative. Because of this negative value, absolute value cannot be negative. This is a no solution. And then likewise in number 5, we take whatever our absolute value is and we want to know what it is to the left and what it is to the right. So we break it out and we say 3x plus 5 equals 4. You write it exactly the same without the absolute value bars. And then we also do 3x plus 5 equals negative 4. So you want to do one with positive and you want to do one with the negative side. So we're going to solve. We have 3x equals negative 1, divide by 3. X equals negative 1/3. over here when we solve, 3x equals negative 9, divide by 3, x equals negative 3. So we have these solutions. And number 5 is going to be one of those values. Okay, number 6, solve, state the domain before you solve. We said we had our three circumstances with domain. It was either all reals, or it was the case in which we have a variable in the denominator, which we set not equal to 0 and solve, or it was the case in which we had the variable under a radical and we set greater than or equal to 0 and solve. So this is our first case. We don't have either one of those situations, so our domain is just simply negative infinity to positive infinity. So it's all real numbers. We have no limitations. Second issue that we have in number 6 is we want to get rid of all the fractions. So let's multiply everything by 6 so that we can get rid of the fractions. Simplify, divide by 3 is a 2, and now I need to distribute. That's going to be 2x plus 2. And then on this next one I'm going to simplify, divide by 2, and now I want to distribute that 3, so, and which is really a negative 3. That's negative 3x, and then I'm going to do negative 3 times a negative 1 is a positive 3, and then 6 times 1 is 6. Add like terms, negative x, add like terms here, plus 5 equals 6. Subtract 5 from both sides. Negative x equals 1. Divide both sides by a negative 1, and x equals negative 1. Okay, let's look at a more difficult one. First of all, we want to do our domain. That means each of these, since there's a variable, cannot be equal to 0. This cannot equal to 0. And this is actually, if I factored out an x, is really x times x minus 4. Which, since we already used both of these, we only have to do it once. So I went off to the side and I set both of this cannot equal 0 and this cannot equal 0, and found that my domain cannot equal 4 and it cannot equal 0. Now, the next thing I need to do is to get rid of the fraction. I need to have a common denominator. Well, since this has an x and this has an x minus 4 in it, this becomes my common denominator. So if I multiply everything by x times x minus 4, x times x minus 4, and x times x minus 4, then this x minus 4 cancels this one, and I'm left with multiplying that to get 5x squared. This x cancels this x, and I have negative 20 times x minus 4, and then I have this cancels this whole thing, so I'm left with equals 80. 5x squared minus 20x plus 80 equals 0, equals 80. Subtract 80 from both sides, and so we have 5x squared minus 20x equals 0. So now we want to look at this. We want to factor a 5x out of each of them. This has a 5x in it, and this has a 5x in it, so we're left with x minus 4 equals 0. Now we set 5x equal to 0 and solve, and then we set x minus 4 equal to 0. And since one solution is x equals 0, the second solution is x equals 4, but since x equals 4, but since our domain says it cannot be 4 and it cannot be 0, this is no solution.